Welcome to the deep dive. Today, our mission is to really unpack some of the most terrifying events in the history of our planet.
And we're not just talking about recent history.
No, not at all. We're looking at disasters so profound, they didn't just change human societies, they literally reshaped the physical course of life on Earth.
That's right. Our sources cover this huge timeline. I mean, we're starting with an asteroid strike from 3 billion years ago.
3 billion. And we're going all the way up to, 21st century tragedies where you see this terrifying mix of natural fury and technological failure.
Exactly. And the goal here is to synthesize all this information. We want to look at the cause, the scale, and the lasting implications.
Right, because it's one thing to hear about a supervolcano, but it's another to understand how it nearly wiped our species out.
And how that compares to something like, say, an industrial accident. The scale is different, but the devastation can be just as concentrated.
We're talking about extinction-level physics, huge cultural shifts,
Yeah.
and some facts that, honestly, you're going to want to remember. So let's get into it.
Okay, so if we're talking about events that can just hit the reset button on existence, we have to start with space, right? The ultimate external threat.
Absolutely. And I think most people's minds immediately go to the dinosaurs.
Chicxulub impact. Yeah.
But our sources,
Mm.
they remind us that there were ancient impacts that just dwarf that. They make the dinosaur killer look almost small by comparison.
So where do we start? What's the biggest?
We have to begin with what's called the S2 impact. This happened about 3 billion years ago.
3 billion. So Earth was still very young.
Very young, yeah.
Yeah.
And the object we're talking about was an asteroid nearly 50 kilometers wide.
50. Okay, wait. The Chicxulub one was what, 15?
Around 15, yeah. So this thing was just, it was monstrous, truly on a different scale.
Its energy released must have been, I can't even imagine.
The estimates are just staggering. It was like 700 Hiroshima bombs all going off in the exact same instant.
The impact didn't just create a crater. It sent a shockwave that literally shook the entire planet, rattling the newly formed continents.
So it's not just a local event. It's a global physical shock.
A global shock, exactly. And it hit the ocean, which meant it vaporized a colossal amount of water and rock.
And that would have changed the atmosphere completely.
Completely. You get these enormous plumes of vaporized material that lead to this wild cycle of first extreme greenhouse warming and then rapid deep cooling.
And a tsunami, I assume.
Oh, mega tsunami.
Yeah.
Something of a height we can't really comprehend today. It would have just scoured the coastlines of the early continents clean.
So that level of climate instability, it's basically a planetary reset button for any primitive life that was starting to form.
That's the key takeaway. It triggered a massive extinction event in that early ecosystem. It essentially delayed the establishment of stable life and fundamentally reshaped the whole trajectory of evolution on Earth.
Okay, so from that planet shaker, let's go to the one everyone knows. Chicxulub, 66 million years ago. It was smaller, but its effect was, well, definitive.
Definitive is the word. So this object, about 15 kilometers wide, probably from the asteroid belt, slammed into the Yucatan Peninsula.
And the immediate effect was, again, just unimaginable power.
Billions of atomic bombs worth of energy. It vaporized everything at the epicenter, triggered massive earthquakes, and sent tsunamis ripping through the Gulf of Mexico.
But the sources seem to place so much emphasis on what happened after the impact, the impact winter.
Yes, because that was the true global killer. The mechanism there was the climate change.
So it's not just dust blocking the sun.
It's more than that. The asteroid hit a very specific type of rock, rich in gypsum.
Ah, so sulfur.
Exactly. It threw vast amounts of sulfur aerosols into the stratosphere, and that wasn't just a physical screen like dust, it was a chemical screen. It plunged the planet into darkness and caused a catastrophic temperature drop that lasted for years.
Which means the entire food chain just collapses from the bottom up.
Absolutely. Photosynthesis stops, plants die, then the herbivores who eat the plants, they starve, and then, of course, the great predators starve.
And in a geological blink of an eye, the dinosaurs are gone. Except for birds, of course.
Right, their avian descendants survive, but for the most part, the age of dinosaurs was over.
And this is where it gets so fascinating, because that ending was really our beginning.
It was the single most important event in the history of mammals. With the dinosaurs gone, these small nocturnal mammals that had been living in the shadows could finally emerge.
All those ecological niches were suddenly empty.
They were wide open, and so evolution favored those mammals that could adapt, that had, more advanced cognitive abilities, and that lineage eventually leads to primates and, well, to us.
We literally exist because of that cosmic tragedy.
We do. Our entire evolutionary history is built on the rubble of that impact.
All right, so we've had the planet shaker and the evolutionary reset. Let's move to maybe the strangest one in this category, the Tunguska event in 1908.
Tunguska is so unsettling because it's a modern event and it shows a different kind of cosmic threat.
What happened?
On June 30th, 1908, over a remote part of Siberia, people saw this brilliant fireball just tear across the sky. It was so bright you could see it hundreds of miles away, even in broad daylight.
But the key thing here is that it never actually hit the ground, did it?
That's the crucial distinction. It exploded in the atmosphere about 5 kilometers up, an airburst.
So all that kinetic energy was released at once, in the air.
All at once, about 10 to 15 megatons worth. And the aftermath was surreal. The blast flattened an estimated 80 million trees over 2,000 square kilometers.
I remember reading the witness accounts describing them all lying like simple matches.
Simple lily Mets, yeah, radiating out from the epicenter. It's an incredible image.
And the accounts also mention the silence. After the huge shockwave, there was this deathly quiet.
Which is so eerie, isn't it? That profound silence, only broken by the sound of all that timber falling. It just speaks to the sheer power of the atmospheric blast.
And the human cost was surprisingly low.
Very low, thankfully. The region was so isolated, there were some local injuries, but no direct confirmed fatalities. Hundreds of reindeer, though, which were vital to the local Evenki people, were killed instantly.
So Tunguska is really a chilling reminder of what an airburst could do over a populated area.
Exactly. It's a modern wake-up call from space.
Okay, so if cosmic impacts are the sudden shock from outside, what about the threat from within, from the ground beneath our feet? We're shifting now to volcanism.
And this is a different kind of power. It can be patient, building for centuries, but when it's unleashed, it can manipulate the entire global climate.
Where do we start? What's the apex predator of volcanoes?
That would have to be Toba. 74,000 years ago in what is now Sumatra. This was a super eruption. We're talking a Category 8 on the Volcanic Explosivity Index, the highest possible score.
I mean, the local devastation must have been absolute.
Oh, completely. It buried vast regions of Southeast Asia under meters of ash. Pyroclastic flows for miles. It turned day into night.
But the real story of Toba isn't local. It's global, isn't it? The volcanic winter.
That's right. It threw so much sulfur dioxide and ash into the stratosphere that it created this veil around the planet, reflecting sunlight back into space.
And that caused a massive temperature drop.
A huge drop. It triggered a volcanic winter that might have lasted 6, maybe 10 years, and kicked off a temporary ice age. The entire planetary ecosystem was disrupted.
Which brings us to this incredible theory, the human bottleneck. The idea that Toba almost made us extinct.
This is a critical moment in our history. The cold and drought caused by the eruption would have decimated food sources. Early human populations would have been pushed to the brink.
So the theory is that the global population crashed.
It crashed. Some estimates say it could have been reduced to as few as 10,000 individuals, maybe even less. A tiny group of survivors, probably concentrated in Africa, maybe clinging to the coasts.
And we can still see the evidence of that in our genes today.
We can.
And that devastation would work its way up the food chain.
Exactly. The volcanic winter and the loss of grazing lands hit the big herbivores hard. Things like the American mammoth. Their populations would have plummeted.
Which in turn affects the predators.
Right. Predators like the saber-toothed tiger, who rely on that megafauna, suddenly find themselves in a world with no food. It was an ecological catastrophe on a continental scale.
Let's shift from these climate-altering events to an eruption that brought down a specific, thriving civilization. I'm talking about Thera, or Santorini, and the Minoans.
This is such a fascinating case study. About 3,600 years ago, the Minoans were the dominant power in the Aegean. They were masters of the sea, based on Crete.
And Thera was a key outpost for them, right? A major trading hub.
A vital one. The settlement of Akrotiri on Thera was a jewel in their commercial network. But beneath that prosperous island, magma was building.
And when it blew, it wasn't just the explosion, it was the water.
The explosion was enormous. It caused the center of the island to collapse, forming the caldera we see today. But the real killer for the Minoans was the tsunami.
How big are we talking?
Potentially 100 meters high. This colossal wave slammed into the northern coast of Crete, destroying their fleet, their ports, their coastal cities. It struck right at the heart of their naval power.
So they didn't recover.
They never fully recovered, no. It was a blow from which their civilization began a long decline.
And this is where we get that incredible connection between geology and myth, the legend of Atlantis.
It's one of the most compelling theories in historical studies. The idea is that the story of this advanced island civilization that was destroyed and vanished beneath the waves in a single day and night.
Was passed down through generations.
Exactly. Passed down orally, probably through Egyptian and Greek traders, until it eventually reached the philosopher Plato.
Who wrote about it in his dialogues, Timaeus and Critias.
Correct. Now, Plato gets the timeline wrong. He says it was 9,000 years before his time, but the description. A wealthy, powerful island culture destroyed by fire and water. It's a perfect match for the Thera eruption. Its history becoming legend.
It's incredible. Okay, let's fast forward to a more modern eruption, but one famous for its sheer sound and fury. Krakatoa, 1883.
Krakatoa was all about the immediate violent power. The final explosions were estimated at 200 megatons of TNT.
And the sound. The sound was heard thousands of miles away.
Almost 5,000 kilometers away in central Australia. People thought it was cannon fire, and the atmospheric shock waves from the blast circled the entire globe for 5 days. You could measure it on barometers in London.
But the death toll, around 36,000, was mostly from the tsunamis, not the blast itself.
Yes, the explosions displaced so much water, creating a series of massive waves, some over 40 meters high, that just obliterated coastal villages on Java and Sumatra.
But Krakatoa also had this strange, beautiful after effect. It changed the sky.
It did. All that fine ash and dust thrown into the stratosphere scattered sunlight in a particular way. For months afterwards, all around the world, people witnessed these incredibly vivid, spectacular red and violet sunsets.
The atmospheric art phenomenon.
Exactly. They were so dramatic that they inspired artists. William Ashcroft in London, for instance, created hundreds of paintings just trying to capture these bizarre, beautiful red skies.
We can't talk about volcanic climate change without focusing on the one that gave us the year without a summer. Tambora, 1815.
Tambora, also in Indonesia, was even more powerful than Krakatoa. It's one of the deadliest eruptions in recorded history. The initial explosion was heard 2,000 kilometers away.
The immediate death toll was huge.
About 70,000 people from the pyroclastic flows, the tsunamis, the toxic gases. But the true disaster, the global disaster, was what came next.
The global cooling.
The sheer volume of sulfur dioxide it injected into the stratosphere was immense, and those aerosols stayed up there, blocking sunlight. The result was that 1816 became known as the year without a summer.
And the effects were crippling for societies that relied on agriculture.
Crippling. In New England, you had snowstorms in June. In Europe, the harvests of wheat and corn failed completely. It led to widespread famine, food riots, social instability across the Northern Hemisphere.
And there's another fascinating cultural echo here, isn't there? Connecting this disaster in the Pacific to one of the most famous horror stories ever written.
There is. That gloomy, cold, wet summer of 1816. Mary Shelley was on vacation in Switzerland with Lord Byron and others. Trapped indoors by the relentless bad weather, they decided to have a competition to see who could write the best ghost story.
And that's where Frankenstein was born.
That is where Frankenstein was born. The somber, gothic atmosphere created by the Tambora eruption literally provided the backdrop for one of literature's most enduring monsters.
All right, moving on from these long-term climate disasters, let's focus on the sudden, brutal speed of things like earthquakes and tsunamis. The historic urban annihilation events.
And we have to start with the most iconic. Vesuvius and the destruction of Pompeii in 79 AD.
The classic story of complacency. They had tremors for days and just ignored them.
They did. They were common in the region. But then the eruption began, and it had two very distinct, very deadly phases.
What was first?
The first was a colossal column of ash and pumice that shot miles into the sky, blocking out the sun and plunging the city into darkness. This ash then rained down, causing roofs to collapse, trapping people.
But the second phase was the real killer.
The second phase, which came around midnight, was the pyroclastic flows.
I've mentioned those before. How fast are we talking here?
Up to 700 kilometers an hour, and at a temperature of 500 degrees Celsius.
So no chance of survival.
Zero. It's instantaneous death. For thousands in Pompeii and Herculaneum, it was over in a second. The heat was so intense it vaporized soft tissue, which is why we have those famous plaster casts of the voids left by the bodies.
An entire city preserved in its final moments.
Exactly. Emperor Titus tried to organize a rescue, but it was hopeless. The cities were buried and lost for centuries.
We see that same blinding speed, that same kind of fatal complacency much later with Mount Pelée in Martinique, 1902.
Yes, Saint-Pierre was known as the Paris of the Caribbean, a beautiful, vibrant city. And for weeks, the volcano was showing signs of activity ash, smoke, tremors.
But local officials told everyone not to worry.
They downplayed the risk, tragically. And on May 8th, the volcano unleashed a pyroclastic cloud.
Not a flow down the ground, but a cloud.
A dense, heavy, roaring avalanche of burning gas and rock that hugged the ground and just engulfed the city in seconds.
And destruction was total.
30,000 people killed, almost instantly. The heat was so extreme it ignited everything flammable and carbonized the bodies of the inhabitants. It's a terrifying example of how quickly a city can be erased.
Shifting now to just pure ground shaking. The Great Shaanxi earthquake in China, 1556, it holds the grim record for being the deadliest in history.
It does, an estimated magnitude 8, but the death toll is what's just shocking, 830,000 people.
Why was it so much deadlier than other, even stronger earthquakes we've seen since?
It comes down to geology and architecture. The region is part of the Loess Plateau, which is made of this fine yellow silt.
And many people lived in caves dug into this soil, right? The yaodongs.
Exactly. They lived in these artificial caves dug into the hillsides. And this Loess soil is incredibly unstable during an earthquake. It liquefies.
So it wasn't just buildings collapsing.
It was entire hillsides collapsing. Entire communities were just buried alive in their homes. The ground itself became the tomb.
The geological turmoil must have been immense.
It was. Giant fissures opened up. Rivers changed their course, which led to even more flooding and destruction. It was the perfect storm of a powerful quake and uniquely vulnerable living conditions.
But perhaps the most philosophically significant event in this category was the Lisbon disaster of 1755. It wasn't just one thing, it was three.
It was a triple threat, and it happened on All Saints' Day, a major holiday. First, a massive earthquake, probably an 8.5 to 9.0 magnitude, collapsed most of the city's stone buildings.
Survivors ran to open areas, like the waterfront.
Which was the worst possible thing they could do. Because minutes later, the sea retreated dramatically, exposing the seabed.
The classic tsunami warning sign.
And then came the wave. A massive tsunami, maybe 15 meters high, that swept deep into the city. And as if that wasn't enough,
The fires.
fires broke out all over the city from overturned candles and cooking fires, and they burned for days, earth, water, and fire. The city was completely destroyed.
And this event, happening in a devout Catholic capital on a holy day, sent shockwaves through European thought.
It really did. It shattered the optimistic philosophy of the Enlightenment. Thinkers like Voltaire were profoundly shaken, asking how a benevolent God could allow such suffering. It forced a major reckoning with the randomness and fragility of human existence.
Let's talk more about megawaves. The Lituya Bay mega tsunami in Alaska in 1958. This holds the record for the highest wave ever, right?
By a huge margin. It was a geological freak accident. A 7.8 magnitude earthquake triggered a massive landslide rock and ice, which fell directly into this narrow, deep fjord.
And that displacement of water created the wave.
It created a wave that slammed against the opposite side of the fjord and ran up the slope to a height of 524 meters.
Half a kilometer high.
Right.
It's not a wave, it's a moving wall of water.
It is, and it literally scraped the trees and soil off the mountainside, leaving this visible scar you can still see today.
And incredibly, someone survived it.
One fishing boat, miraculously. The crew described being lifted up and over this towering mass of water, an absolutely incredible survival story.
So you have that natural event. Let's contrast it with the man-made one. The Vajont Dam tragedy in Italy, 1963.
Vajont is a textbook case of human engineering hubris ignoring clear geological warnings.
What happened?
They built this huge dam next to a mountain, Mount Toc, that was known to be unstable. As the reservoir filled up, the water pressure lubricated the unstable rock layers.
And the mountain started to move.
It did. There were documented slides and warnings for years, but they were ignored. Then one night, a massive chunk of the mountain just collapsed into the reservoir.
And it created a wave.
A gigantic wave that went straight over the top of the dam. The dam itself actually held, and it just annihilated the villages in the valley below.
Wiped them off the map.
Completely. Nearly 2,000 people were killed, most of them in their sleep. A horrific and entirely preventable tragedy.
And finally in this section, the 2004 Indian Ocean tsunami. A truly global-scale disaster in our modern era.
It was triggered by a massive 9.1 magnitude earthquake off the coast of Sumatra. The seafloor was uplifted, displacing an incredible volume of water.
The sheer scope was what was so shocking. It hit 14 different countries.
From Indonesia and Thailand all the way to East Africa, over 230,000 people died.
And again, we see that tragic misunderstanding of the warning signs, the retreat maritime.
Yes, the sea pulling back. In so many places, people, especially tourists who didn't know, were fascinated by it. They walked out onto the exposed seabed to collect shells.
And then the wave came.
And then the waves came, some as high as 30 meters. It was a brutal lesson in the need for global tsunami warning systems and, just as importantly, public education.
Okay, let's pivot to the power of the atmosphere itself. Meteorological extremes, wind and water.
And when we talk about wind, we have to start with the tri-state tornado of 1925 in the U.S., the deadliest in American history.
What made it so unique, it wasn't just its strength, it was its persistence.
Its persistence and its path length. It was an F5 super tornado that stayed on the ground continuously for 219 miles across 3 states, Missouri, Illinois, and Indiana. It was just this relentless engine of destruction.
Nearly 700 people were killed.
Yes, it just leveled entire towns like DeSoto, Illinois, a terrifying demonstration of what happens when all the atmospheric conditions align perfectly to create a monster storm.
Compare that to the Dholapur Saturia tornado in Bangladesh in 1989. Here, extreme wind met extreme vulnerability.
Exactly. The winds were over 400 kilometers an hour. But it hit an area where most homes were simple mud and thatch structures. They offered zero protection.
They were just ripped apart.
Instantly. And the result was 1,300 deaths and the almost total loss of livestock, which crippled the local economy. It's a stark reminder of how socioeconomic factors amplify the deadliness of a natural disaster.
Now let's add water to the wind. The Bola cyclone, 1970, in the Bay of Bengal.
One of the deadliest storms in all of recorded history. The winds were up to 185 kilometers per hour, but the real killer was the storm surge.
The low-lying Ganges Delta is incredibly vulnerable to that.
Incredibly. The surge was up to 10 meters high, and it just inundated the entire region. The death toll is estimated at over 300,000 people, possibly as high as 500,000. Most died within a few hours.
But the sources point to a major political fallout from this disaster. It was more than just a storm.
It absolutely was. At the time, the area was East Pakistan, and the response from the central government in West Pakistan was seen as completely inadequate and indifferent.
And that fueled massive resentment.
Massive resentment. It fed into the existing tensions and became a major catalyst for the Bangladesh War of Independence the following year, a weather event that directly contributed to the birth of a new nation.
Let's transition from cyclones to just pure water.
Okay.
Great floods.
Yeah.
Starting with the Yellow River flood of 1931 in China.
The Yellow River is known as China's sorrow for a reason. In 1931, after heavy snowmelt and then a series of typhoons and torrential rains, the river just completely overwhelmed its dikes.
The scale of the flooding was continental.
Millions of hectares were submerged, and the death toll, it's just horrifying. It's estimated between 1 and 4 million people.
4 million? How is that even possible?
It's because the initial drowning was only the beginning. The real killers were what came after. Disease, cholera, typhus, and then the mass famine because all the crops were destroyed. It was a prolonged, unparalleled humanitarian crisis.
And finally, in this part, let's touch on the mythic floods, Gilgamesh and the Bible. These stories from different cultures seem to share a common, deep memory.
The parallels are striking, aren't they? In the Epic of Gilgamesh, you have Utamishtim, who is warned by a god to build a boat. After the flood, he sends out birds to find dry land.
And in the Bible, you have Noah, warned by God, builds an ark, sends out a dove.
The structures are nearly identical, and the big historical debate is, what real event could have inspired these enduring myths?
What are the main theories?
One is a massive but regional flood in Mesopotamia between the Tigris and Euphrates rivers. It's a very flood-prone area.
But there's a bigger, more global theory too, right?
Yes, the idea that these are an ancestral memory of the massive sea level rise that happened at the end of the last ice age, around 12,000 years ago. As the glaciers melted, coastlines all over the world were submerged.
So it might not have been one single flood, but a long period of inundation that was remembered as a world-ending event.
Exactly. Something like the Black Sea deluge hypothesis, where the Mediterranean catastrophically broke through and flooded a massive freshwater lake, could have displaced entire cultures and created a legend that lasted for millennia.
We now enter a totally different category of disaster. Not cosmic or geological, but man-made. Caused by our own technology, our own errors.
And we have to start with the definitive nuclear trauma, Chernobyl, 1986.
This was a story of human error, wasn't it?
Did.
A safety test gone horribly wrong.
It was a sequence of human errors. The operators were running a test, they reduced the reactor's power too low, and they disabled key safety systems to do it. But the real problem was the reactor itself.
The RBMK reactor design. What was the fatal flaw?
It had what's called a positive void coefficient, which is,
Yeah.
it's a bit technical, but what it means is that at low power, if the water coolant turns to steam, the nuclear reaction actually speeds up instead of slowing down.
Which is the exact opposite of what you want. It's inherently unstable.
Wildly unstable. So when they were in that low power state and a power surge started, their attempt to shut it down actually made things worse.
Then at 1:23 a.m., the explosion.
A massive steam explosion that blew the 1,000-ton concrete roof right off the reactor building, releasing a plume of deadly, invisible radiation into the atmosphere.
31 people died immediately, but the real toll was the radiation.
Yes. The evacuation of Pripyat, the contamination across Europe, it was a lesson that the most complex technology can have a single fatal flaw that human error will eventually find.
Now, contrast that with Fukushima Daiichi in 2011. Here, the trigger was natural, but the failure was still technological.
Right. A massive magnitude 9 earthquake hits. The reactors do what they're supposed to do. They shut down automatically.
But then came the tsunami.
A 40-meter tsunami that just overwhelmed the plant's seawalls. And the critical failure was that it flooded the backup diesel generators.
So they lost all power.
They lost all power to the cooling systems. And without cooling, the reactor cores started to overheat.
Which led to hydrogen explosions.
Exactly. And the release of radiation. Fukushima showed that your safety systems are only as strong as their weakest link. In this case, the assumption that a tsunami could never be that big.
Let's talk about a different kind of man-made killer. Bhopal, India, 1984. The silent, invisible chemical disaster.
Bhopal is just chilling. A pesticide factory had a failure in its safety systems, and it released a huge cloud of highly toxic methyl isocyanate gas.
And it happened in the middle of the night.
Around 12:30 a.m., the gas is heavier than air, so it just hugged the ground and spread silently through the sleeping city, affecting 500,000 people.
The death toll was immediate and staggering.
About 3,000 died within hours. That number eventually rose to over 15,000. But the true horror of Bhopal is the legacy. The contamination is still causing chronic health problems, birth defects. It's a disaster that never ended.
Moving to pure explosive power. The Halifax explosion in 1917.
This was just a tragic accident of wartime logistics. A French cargo ship, the SS Mont Blanc, was loaded to the gills with explosives for the war in Europe.
And it collided with another ship in the harbor.
It did. And the resulting explosion was the largest man-made blast the world had seen before the atomic bomb. About 3 kilotons of TNT.
And it didn't just explode, it created a chain reaction of destruction.
The blast wave flattened a huge part of the city. It created a tsunami in the harbor. And it caused massive fires. 2,000 people killed, 9,000 injured. A city devastated in an instant.
There's an even earlier, more mysterious blast. The Wangongcheng explosion in Beijing, 1626.
This one is bizarre. A massive explosion at a munitions depot in the Ming capital. Witnesses described a mushroom cloud, which is an incredible detail for that era.
But we don't know what caused it.
We don't. It could have been an accident with the gunpowder, maybe sabotage, but the result was 20,000 people dead and a large part of the city reduced to rubble. One of history's great unsolved disasters.
Okay, let's end this section with something that wasn't a disaster in its time, but serves as a critical warning for us today.
Yeah.
The Carrington event of 1859.
This was a massive solar flare, a huge geomagnetic storm from the sun that hit Earth.
And in 1859, the effect was kind of a novelty.
Mostly, yeah. The northern lights were seen as far south as the Caribbean. The only real technology it affected was the telegraph system. Lines sparked and caught fire. It was chaos for telegraph operators, but that was it.
But if that same storm hit us today...
It would be a civilization-level catastrophe. Our entire world is built on fragile electronics.
So what's the specific threat? What would fail first?
The power grid. The geomagnetic currents would surge through the grid and burn out the massive, custom-built transformers that are the backbone of the system.
Leading to widespread, long-term blackouts.
Months, maybe years in some places. And then there are the satellites, GPS, global communications, the timing systems for financial markets. All of it would be crippled or destroyed.
It would be a complete societal breakdown.
It would. The Carrington event is maybe the most serious natural threat we face, precisely because our modern world is so uniquely vulnerable to it.
All right, for our final section, let's look at some very specific, sudden, and often very strange environmental cataclysms.
And we have to start with one of the most unique and terrifying, the Lake Nyos limnic eruption in Cameroon, 1986.
This wasn't a volcano erupting, it was a lake.
A volcanic leak, yes. And over centuries, CO2 gas from magma below had been seeping into the deep water of the lake, dissolving under immense pressure. The lake was like a giant, unshaken bottle of soda.
A bottle of poison.
A bottle of poison. And then something disturbed it. We think a landslide. And the lake suddenly overturned, releasing this massive invisible cloud of CO2.
And because CO2 is heavier than air?
It flowed down the valleys like a river, displacing all the oxygen.
That silent killer.
The ultimate silent killer. It suffocated 1,700 people and thousands of livestock in the nearby villages, most of them while they slept. They never knew what hit them.
Just horrifying. Let's move to a climate shock caused by water, the 8.2 kill-year event.
This is a fantastic lesson in how the climate system is all connected. So at the end of the Ice Age, a huge ice sheet over North America was melting, creating this enormous glacial lake called Lake Agassiz.
And it was held back by an ice dam.
An ice dam, which eventually failed, catastrophically. A colossal flood of cold, fresh water poured into the North Atlantic.
And this influx of fresh water disrupted the ocean currents, didn't it?
It disrupted the main heat engine for the Northern Hemisphere, what scientists call the AMOC, the Atlantic Meridional Overturning Circulation.
How does that work?
Basically, warm, salty water flows north, cools, gets denser because it's salty and sinks, driving this global conveyor belt. But this huge flood of light, fresh water, put a cap on the ocean and stopped that sinking.
So the heat pump shut off.
It effectively shut off, and the result was an abrupt 200-year-long cold snap across the Northern Hemisphere. It devastated the first agricultural societies in Europe and the Middle East. It shows how quickly the climate can just flip.
Finally, a very localized but incredibly powerful event. The Yungay avalanche in Peru, 1970.
This was triggered by a big 7.9 earthquake in the Andes. The shaking dislodged a massive chunk of a glacier and rock from the mountain above the town of Yungay.
And it created an avalanche of mud, ice, and debris.
A massive flow that came down the mountain at hundreds of kilometers an hour.
And the town of Yungay was directly in its path.
It was completely buried, wiped off the map in about 3 minutes. Out of 25,000 inhabitants, only about 400 survived.
And there's that incredible heartbreaking detail about who survived.
It's one of the most powerful anecdotes in all our source material. Almost all the survivors were children, because at that exact moment, a traveling circus was in town, and it had set up on a high piece of ground above the city. The children had all gone up the hill to see the circus.
And they watched their town disappear.
They did. A bizarre, tragic twist of fate that saved a few hundred lives.
So we have covered an incredible amount of ground today, from the S2 impact on a world that was barely formed, all the way to the silent CO2 cloud from Lake Nyos.
It's been a journey through cosmic fury, geological power, and our own technological failures.
And a clear theme emerges, doesn't it? On one hand, you have the almost incomprehensible scale of ancient events like Toba or Chicxulub.
Power that's just beyond anything we can really grasp. And on the other hand, you have the very concentrated, specific dangers of our own making, like the design flaw in a reactor or a toxic gas leak.
The sources really confirm that existence is this profound mix of extreme fragility and somehow incredible resilience.
Absolutely. Life finds a way to persist even after these planet-altering events. But we've also seen how easily our own systems, our cities, our agriculture, our technology can be wiped out in an instant.
Which brings us back to the lessons of the past.
It does. When you look at the events that caused rapid global cooling, the impact winters, eruptions like Tambora, it shows you just how delicate that climate balance is. And this raises, I think, a really important question for you, the listener, to think about.
Go on.
Imagine you woke up tomorrow and the sky was just dim, not cloudy, but hazy, and it stayed that way for days. The sun was this pale disk. Knowing what you now know about impact winters and volcanic cooling, what would your immediate practical steps be?
How would you react in those first hours?
Exactly. How would you prioritize conserving heat, light, finding reliable information, knowing that this could be the start of a prolonged period of darkness and cold?
That's a very provocative thought. It really forces you to take these historical lessons and apply them to your own reality.
That's the goal.
Well, we hope this deep dive has given you a comprehensive and maybe a little sobering understanding of the forces that have shaped and continue to shape our world.
Continue your own deep dive into these incredible stories. We'll see you next time.